Thanks. Hello, everyone. Can you hear me well? Yeah, can you see the screen? Okay. So I propose to start. So thank you for being here. It's almost the end of the Hack.lu, but still you are brave to be here. So today's topic is modern penetration test tricks for faster, wider, and greater engagement at the end. So let's start just a few information, a bit of context. Who am I? Just an InfoSec passionate. Maybe you ever use one of my tools, I don't know, on GitHub. Just say hello if you say so, if you did so. So that's just me, a French guy. So today's agenda, a bit of context. So why do you need, as penetration tester, you need to adapt your techniques and your methodologies, then the tricks, and at the end, a small conclusion about the tricks we should see. So let's start. So what technically changed during that decade for penetration testing and computer science on the whole about security? First, it is possible now, right now, to scan the entire IPv4 space in few minutes, hours or days. So a few attempts at the beginning of that decade with census. Then currently with asynchronous programming, ZMap, Masscan, Unicorn Scan, I guess you know these tools. And mostly the third-party platforms that provide you some data sets that you you don't even need to perform your own scan if you want to. So I guess you know this platform. Who in this room knows about Zoomai? Who ever heard about Zoomai? So everyone's talking about Shodan, but Zoomai is the Chinese Shodan. It provides good data also. You should try it. Scans.io at census.io. Sure. You can also query all those open source information you want by building your own platform, centralizing everything online by querying a lot of cool services. ReconNG, which is a framework, not a service. Domain tools, PastBin, certificate transparency, have-I-been pwned, and many more. So just take a look at that link. It indexes a lot of stuff. It's really cool. And most interestingly, you can now pawn large Windows corporate infrastructures in really few minutes, few clicks, few commands with Reconnaissance, starting with Reconnaissance, PowerView, Blowdown to chase admin and assets. Then exploitation. I'm sure you know about CrackMapExec, Responder, and a tiny and small attack vector named Kerberoasting, which is really useful. Then for post-exploitation, Mimikatz. You know it. Invoke Mimikatz when you want to be stealthier, or even Empire when you're professional, you want to automate a lot of stuff, just like Metasploits. Or you can automate really everything, every steps in the star. So it is done by the guy behind CrackMapExec, by Bleeder, which is really cool also. So why do you need to adapt your techniques? Because frankly, from many years ago, we can observe that more and more security folks, write more and more tools. That's the first observation. The second one is that the tools are good quality and reliable, which haven't been the case from the beginning of InfoSec. Remember Netcat, the first version of Netcat were vulnerable to a buffer overflow. So useful for attack, but yeah, you should take a look at also at the code you are executing. Because you will be asked to cover wider scopes. In my past few engagements, I was asked to cover like hundreds of thousands of assets for large companies, to perform some configuration reviews, like 10 control points on each, and to cover a worldwide scope. So and to pawn the whole world. So for this company, so really you will be asked to cover wide scopes. And to be frank, it has already changed. You really need to adapt your techniques to cover wide scope faster and better. You don't have to choose fast, like you don't have to choose fast or good quality or stuff. You can do everything, but you need to scale right now. So enough context. Let's start with the first tricks, the first observation I did throughout my years of pen testing. So as you know, there's a lot of iterative work in our field. You know this kind of wheel. You scan some targets, you exploit them, you harvest and you find some new data, and you use the newly found data to other targets or even previous targets to gain some more intelligence on it. So you need a good data format to process all of this. I recommend CSV. I'm not saying CSV is the best format for everything. I'm saying it's the best format for humans. It's a common format, widely used, but mostly it's a human-readable format, unlike JSON or XML. And as you are humans, I guess, if you complete the Turing test, you should use CSV. It's a rather simple format, but there's no standard. There's no RFC or so on, or true standard on CSV. So there are some traps like in encoding and in quoting. So please use UTF-8 and quote everything. So here in this example, I advise you to quote everything, every field. Not this one, not to use that format without code, because you will have some mess at any point. And one last thing, you have your injection even in CSV. So don't trust CSV you cannot trust. Don't open CSV you cannot trust, yeah. Because even in Excel you can exploit some stuff. In short, use CSV as much as possible. So to use it, you need some tools to provide CSV stuff. So first, I will just show you some few cool tools commonly used in penetration testing that offer CSV support for input or output or both, starting with Nmap to CSV, which is a tool I did to provide and to scan Nmap result to CSV. Then you have wfuzz, just like Jarbuster, but better and modern. TestSSL.sh to really have a great insight on your SSL layer. Blowdown, you know it's Off-Crack, the legacy and old school password cracker. ReconNG, which is a cool OSINT framework. And Icto, again, a legacy and useful web scanner. And finally, Nessus. And I could even quote Qualys. This is the same kind of idea. Nessus and Qualys offer CSV output. So now you have a CSV, how you can handle it with tools. So first, don't leave that room because I'm talking about Excel. There will be really more advanced tricks that using Excel, but you need to know that with Excel you can open easily CSV. That's a good format for it. But the main drawbacks is that the max line of Excel is only 1 million. 1 million is very short in our world now. Remember when I was asked to cover hundreds of thousands of assets for big companies, I had to perform a configuration review on 10 control points on each asset. So I'm directly at 1 million lines in my file, and Excel cannot handle it. So you really need to work differently. That's the point. Right now, even in Excel, there are some new features, starting with the current version of Excel, the latest one. You have a module named Power Query, which is a useful module a native module to perform some pivots, some join between data, and really better than before. So still the max number of lines is still a problem and is still present, but maybe you can find some easier stuff to do with Excel. So right now, some more advanced stuff. CSV Kit. Who in this room knows about CSV Kit? Very few people. If you work with CSV, you need CSV Kit. CSV Kit is a suite of command line tools. It really changed my life quite recently, but there's a lot of tools, specific tools, just like the Unix philosophy, one tool to perform one simple task and do it good. So to manage your input, you have CSV clean, CSV format, just to convert and to go from a unquoted to a quoted stuff, comma or semicolon and so on. Then for processing, the most exciting stuff is maybe CSV join and also CSV SQL, because with this kind of tool, a CSV file is no longer a dumb file. It is a real database. You can perform SQL queries, not injection, but queries on a CSV file with this kind of tool. It is really awesome, and it really changed my life and my way of doing my work related to the other tools I mentioned you just before. But this kind of tool is really useful for your CSV. Some demo. I have a lot of demos to show you. Just let's start with one direct and simple example, which is CSV stat. CSV stat is just made for one thing: printing stat or CSV file. It's pretty dumb, but here I will be processing a small Nessus result, a really small Nessus result, and you will see what it looks like. So it parses the whole columns, and it can print some different stuff about the column, some numerical computation. So the mean, sum, and so on. The most frequent value. So maybe right now, if we move to CVE, you can see that the most frequent value on my Nessus file is this kind of CV. It can give you some insights about what's to be done and what's really cool in your scan, in your result. So let's say now I do know which column I want to filter, just for better precision. I'm using CSV stats, just filtering on some columns. And here, again, the same kind of result. You can see some insights. So here I'm filtering on plugin ID. Filtering ID, plugin ID, sorry, CVE, CVSS, and so. So, again, a lot of insights that you can then analyze. And here you can see, even in the name column in a Nessus report gives you like the missing, for Microsoft stuff, it can give you the missing Microsoft patches. So you directly see which one is really missing, the most frequent values. Then, as I told you, let's have a better approach, like doing like an SQL queries on the CSV file. That's what I'll be doing. Sorry. Here, the first option is just saying which kind of format do I have with semicolon and everything quoted. And then I perform the query, so you can recognize select host command name. Name is the field that you can see the Microsoft missing patches from my Nessus file, where name contains like this good old vulnerability that you may know of, you might be aware. So I just directly want to filter, and I want to pipe it in a CSV look stuff. It can look really good in your terminal. So here you can see that this is anonymized data, but with this kind of request, you can directly see in a large report which host is vulnerable to this kind of stuff. That's pretty cool. I hope you're convinced, but that's really cool. To perform some SQL queries in a dumb flat file is pretty new to me, and I think to you also. Then let's move on. So that was the first demo of CSV Kit, which I really encourage you to use. The second one is not a better, but a different tool, mostly related to data science. It's not a security tool at all. It is called Hack.lu. It's a really cool tool. It's a user-friendly with a graphical. I will show you just after some demos, but it's a very intuitive and user-friendly stuff, and it allowed me to do some stuff I could not do without it. That's the definition of big data. So to give you an example, I could easily filter and join some file. On one hand, I had 30 gigs uncompressed file with a hash and a login. And on the second file, a 4 gigs file, I had a hash and clear text file. I wanted to join this to provide a cool view, like you can imagine, like in a database leak on the internet. When you want to go from login hash to go from this to login hash and cracked password, which is really easier to see and really practical. So with this kind of machine, which is pretty lame, 4 cores and 16 gigs, it takes only 4 hours. This is pretty awesome to perform the join, a real SQL join between a 30 gigs file and a 4 gigs file. So that's pretty amazing, and that's the power of data science today, and this kind of tool such as Hack.lu. There are some cool tutorials on their website. I just encourage you to see them. So it looks like this, really, the Hack.lu. You write some recipe here. I can write some data preparation recipe, join, and so. Already 10 minutes? Wow. Okay. I will move really forward. Here you can see that you can easily look at some stuff, easily filter, easily draw some charts, even like click and go. So that's it. Then let's move to the second trick. Parallel execution. So in our work, every time extract some results, launch some different tasks. We want to multitask. We want to multi-thread everything. And when you cannot do it easily because your tool is not made with multi-thread inside, you need an external tool such as GNU Parallel. I don't know if you know it, but GNU Parallel is a Perl script to parallelize any command on a Unix system. It's a replacement of Xargs, and it has a lot of more options than Xargs progress bar, job resume, and even SSH login to distribute the task among different servers. So at the end, my work, when I work, it looks more, my HTOP looks more like this than this. So I'm really happy that my machine is really computing some stuff. An example, an application example of parallel. Here I have a target list. I'm using wfuzz to enumerate. It's not 10 minutes. Okay, yeah, that's thank you. Here I'm using wfuzz to perform a URL discovery task on every target that you can see here simultaneously. Instead of going from like 1 to 3 and starting over to the 3 next one, I'm doing for every target simultaneously just to speed up the process. That's really cool. And here you can see the power of parallel. You can input in your command, in your process, some direct perl/sed expression to remove bad chars in file name in the outputs, because here that you can see my entry, my input file contains some bad characters for Unix. You can write some file with this kind of character here, colon and // So here I'm just replacing them inline through the process. And I can even automate, like when I do have the wfuzz result, just to pipe them to another tool called web screenshot. If I want to, after discovering which URL are really accessible, just try to perform some screenshots. So web screenshot is a tool I did also, it's a simple tool to take some screenshots about URL. So you pipe URL discovery and URL screenshotting with two commands, two crafted commands that you can replay every time. You can adapt. And here you have your first step of work of penetration testing done. And you can concentrate and focus on more interesting stuff than just typing some two commands and following them, starting over, resuming some jobs and so on. So you just give it to parallel and you just focus on other stuff. Another example is another common step is DNS enumeration. When you want not only to perform URL enumeration but DNS enumeration, you can pipe parallel, for example, which has subdomains as the input file, and dig, which is the DNS resolver. Don't use NSLOOKUP, use dig. And with parallel, it looks like really cheap to perform this kind of stuff. Just look at the blog post from Mubix. In 2014, he was saying that it was a cheap method, but it is really cheap compared to a proper optimized tool. Let's do the computation. So I tried. So I used GoBuster, which is a Go utility to perform a lot of enumeration, not only in DNS, but you can do DNS enumeration with it. It's Go language, so it's natively multi-thread, multi-processed. It's a compiled by a native binary. And I will compare it to parallel plus dig. So by enumerating some domains, for instance, Google, that was the test, it took me 22 seconds to perform that enumeration, while with parallel and dig, it took me only 27 seconds. So it's like 30% overhead. I don't consider it as cheap as possible because from a proper optimized tool, you only have a 30% overhead with some really native tool. You don't need the Golang environment and so on. You just need parallel and dig, which dig is pretty present on every distribution. For parallel, you can easily install it with apt yum and so apt install parallel, and that's okay. And you will mostly find parallel than go on a standard and common server. So I don't think it's pretty cheap, and it really works. You combine some parallel stuff with some native tool, you combine them, and you have like an almost optimized tool. That's pretty awesome to me. So yeah, let's move forward for more interesting demo. I had a demo just to show you what dig plus parallel looks like, but I will kind of focus on more interesting demos. So third advice, use a high-level scripting language for easier static and dynamic analysis of binary. So because pentesting sometimes involves some custom / what the fuck obfuscation or encryption. Why? Just because people do not understand crypto. That's a fact. And they reinvent the wheel every time. Sometimes you don't want to go down the rabbit hole to figure out what's that fucking custom what the fuck crypto is doing and why it has been invented by some creepy people. sometimes you cannot just replicate and rip the code into your favorite language. And for example, I was looking at how Oracle WebLogic Server encrypts its local password. So it's using PBKDF, PKCS12, SHA-1 plus RC2. And at that time, if you know the crypto system, you want to replicate it in another language, you need your favorite language module to perform it. But at the time, no Python module was existing to support that crypto system. It was Oracle WebLogic Server was using Bouncy Castle from the Java world. If you want to do it in Python, it wouldn't exist at the time. I don't know if it's still the case or not. But the answer to this is to use a high-level scripting language in your favorite language, but instrumenting some different language. You will see what that means just after. So let's start with Jython. So Jython is a tool, is a framework or a suite of language that allows you to write Java code in Python. So with the Python syntax, coding Java code, you can use in the same line, I would even mean, you can use either Java classes and Python libraries in the same line with Python syntax, which is pretty convenient, I guess, for you and for me, because I don't like Java, as I don't like to compile some stuff. I don't like semicolon, brackets, and so on. So I really like to perform some stuff in Python. Then you also have the same for .NET application, like IronPython, which again can allow you to write .NET code in Python syntax, mixing .NET classes and Python libraries in the same script. This is really awesome. Who in this room ever heard about Jython or IronPython? Oh, some hands, that's cool. And finally, for everything else, when you want to instrument everything else, just use Frida, because Frida allows you to write some Python or JavaScript or QML or Swift or .NET to inject some C++ scripted in JavaScript through the Google engine to instrument assembly, Objective-C or Dalvik on Windows platform, Mac, Linux, Android, and iOS. That's awesome. So use Frida as much as you can, and IronPython also, and Jython. But Frida, you can do everything with Frida. So just to have like an example, on the left, you will see like a classical Java code doing encryption, cryptography. You recognize the Java bullshit with secret key spec, cipher, IV parameter spec, and all the classes. The do final stuff also, which is I never understood why. But and on the right, you have the Jython version of it, calling the same classes, but in a different syntax, in the Python syntax. So you recognize, I named the variable the same, but you recognize that you can call the same classes. I'm doing the same Java crypto with the Python language, Python syntax. And it has some real world application. I did my script to decrypt WebLogic password. I could not do it in Python, so I did it in Jython. So you just need Jython again, apt install, yum install Jython, and that's it. Let's have a demo for this. Just to show you that it's pretty, I want to convince you that it's pretty easy to use. So here, I will just show you, yes, example, a simple Jython script. So it's pretty simple. You recognize the classes, you recognize the stuff. I'm just encrypting Euroswag with the Java classes with the Python syntax. And how to execute it? It's as easy as this. You will see the result here. So I'm just printing the X version and the plain text. Plain text doesn't mean anything, but here, do you see how easy it is to use and to instrument Java in different languages? Now you have the same, I can show you the same for .NET. So here, I have a script that I can show you. Let me check. Here I'm playing with DP API. Who knows DP API in the Windows world? So DP API is the common way to encrypt and a secret way to encrypt data on your Windows platform, because it's using not hard-coded keys or so on. It has only two methods, protect and unprotect, and it can encrypt with the user context, so the user hash, password, account, or the machine accounts. So it can protect you on shared machine, if you encrypt some stuff with a user context, like a service account or human account, it can protect this data from decryption from other users. So you need to be the good users to be able to decrypt the correct data. So here, you can play with .NET and C# code and so on, but with Iron Python, you can also do it. And again, instrument the data, instrument the classes. I'm calling the real version of .NET classes. So just to show you, I'm calling the Iron Python interpreter, giving it my proper script, and here I'm just showing you that again I encrypted Euroswag, and here you can see the raw user DP API encryption. This is bullshit. This doesn't mean anything, but it can show you that it works, and with some simple script you can instrument different languages and different core classes. So that's pretty convenient. And so I was just, again, the script looked like this, so you recognize different classes, and it has a first, I guess, real-world application. So a few weeks ago, the guy behind CrackMapExec, Bikebleeder, released at DerbyCon, I think, a cool post-exploitation tool, which is called Silent Trinity. So Silent Trinity is a native binary embedding the Iron Python interpreter, and as a C2 for C2 communication and further code exploitation and code execution, you don't send C# or .NET stuff. You send some Iron Python script, and the native binary embedding the Iron Python interpreter will interpret them. So you have the power to escape from PowerShell logging, PE logging, malware analysis, PowerShell malware analysis. So you move everything to .NET and C#, but here you have the practical stuff that you can perform some operation with as Python language, which is pretty easy and convenient. So again, our first real-life example. And finally, maybe the latest but not the least trick is to compile Python scripts on the fly, because in many cases you need to have a compiled version of tools independently of your language, independently of your targets and so on. Sometimes you're on the target, but you don't have the proper tool execution environment. Let's say, I think you ever messed with PowerShell versions, like PowerView or Kerberos scripts and so on, not having the proper PowerShell version installed on your target. And you cannot install some stuff because you are not root, you don't have any outgoing connection to the internet also. You are lazy. That's a good excuse. You cannot have a proper reverse shell or Metapreter because Metasploit fails again. I don't know. And maybe because you just want to evade some antivirus. So one advice is to compile everything, compile your favorite Python tools with PyInstaller. What is PyInstaller? So PyInstaller bundles a Python script, your script, with a Python interpreter in a native binary. So how to do it is, again, pretty easy. Just install one compiler for your target, not on your target, but on your hosting machine. Just install pinstaller with pip, and then just pinstall your script. So pinstaller option and your script, and that's it. And you can even cross-compile binaries for Windows from Linux with Wine. Just Google Translate this. I know this guy, Thanatos, I haven't met him, but I know he's here. So thank you, guy. Thank you. I showed that trick, and I will show you just after, then it works. It works for that trick. So PyInstaller is really awesome. The options you will love are, first, one file. You package everything in one standalone file. Or, if the file is too big, which happens, I will just give you an example just after, but if you don't want one file, you can have at least one directory. That's pretty, again, convenient to zip and to move and to port to everything else. But one day create a single directory with everything, because in one of my cases, I compiled a cool tool named Patator with every dependencies. You will see just after, again. I'm not disclosing anything, but the final executable was really too big, like 20 megs. And when you click it, when you want to execute it, the first step is to unzip everything, and it takes really a lot of time. And maybe one directory is better to have everything and to have a quicker execution time. You have also, when you want to evade antivirus, that works really. you can provide a custom key, encryption key. Of course, the key is included in the zip payload in the native binary, because the binary should be able to decrypt and to decrypt itself to execute it. But still, just with the key, you can evade some antivirus. And then you have the icon option, to provide an icon file just for visual fanciness. So again, real life example of script compiled with this. The first is a suite of tools coming from Impacket. Who in this room ever use Impacket? Who knows about Impacket? So few hands. Impacket is the framework, the most used framework to interact with Windows stuff, from files, network, domains. It's a core framework that's really awesome. It has several examples doing some tiny tasks, again, like in the Unix philosophy. And I managed to compile every example to a standalone binary that you can drop where you want. And trust me, it is used mostly by guy. In many reports, I found that some black hat people are really using them to attack some real life infrastructure. So it works. What are the examples coming from Impacket? I don't know if do you recognize some tools like psexec, not the sysinternal psexec, the Impacket psexec supporting hashes and so. You have a Mimikatz one, you have NetViews, you have everything else. The golden stuff are Mimikatz again, NTLM relay. I'm sure you know what is an NTLM relay and what's the use for. psexec supporting hashes again. SAMR to dump from a remote location the local SAM database on your target. Secrets dump, which is used to parse ntds.dit file, the database file from Windows domain. SMB exec, SMB relay, again. Ticketer, just to create easily golden, silver tickets, playing with Kerberos. That's pretty useful. It's really easier than using Mimikatz, really, to use Ticketer. Two times here. WMI exec, when you want to be stealthier, not using the SMB protocol, not using the psexec version. WMI persist, WMI query, just to perform some raw query on the target. That's pretty cool to have everything packed in a single executable. The best use case I found is really related to secrets dump, because again, in large engagements, I had a lot of domains. I managed to pound all of domains. I wanted to extract the database. I had like 10 domains. Every domain I had like 10 gigs, at least 10 gigs or 20 gigs of database. And if you want to collect 10 times 20 the raw database to your laptop, you need some spaces that I didn't have. You need a good network connectivity, which maybe I had, I don't know, but it was really heavy. So I just dropped secrets dump to the local target, and I processed and I parsed the data locally, and I just extracted the result from secrets dump, giving me the hashes and the user database. You go from 10, 12, 20 gigs to a few megs. That's pretty convenient to gather them instead of gathering few gigs. Again, Patator, that was the tool I was mentioning. So Patator is a multi-purpose brute force tool. You can brute force everything. That's a legacy and old school stuff, but really good. So you can see all the protocol it can brute force. So I managed to compile everything in one binary, and that was a challenge because, as you can see, it supports different protocols. Each protocol has its Python library, Python module. Each Python module has its dependencies, and you have to pray that every dependencies will fit in one binary. And at the end, it works. But the binary is just 18 megs, and that's a bit long when you want to execute it, but it works. And even inside, so in one tool, one standalone executable, you have everything. You're able to brute force all of these processes and all of these protocols. That's awesome. Then, CrackMap exec. My version is really used mostly by black hats in federal reports. I can often read that they use this. And then, so let's finish with a demo. It happens a lot. It happened a lot to me. You are doing your penetration test. You need a cool Python tool, and it is a mess to install it, and you cannot install it again on the target. And so Hypervote, what was the purpose? It's a cool tool to channel traffic via SOX4 or SOX5 protocol. It works just like SSH dynamic port forwarding, but without SSH, and you can do in opposite direction. So you don't need SSH at the client, the server. You don't need this, and mostly you can do reverse port forwarding. That's pretty cool, and that's native Python, no external module. This is really cool. So it happened to me like I wanted to compile it just to drop the client on the target side. So you need to drop the client on the target. You need the server to be waiting and listening on your attacking machine. So in the next demo, I will be compiling from Windows the client, just Windows for Windows. From a Linux box, I will be compiling the server for Linux, because Linux is my attacking machine in that case. And I will cross-compile, thanks to Thanatos tricks, cross-compile the clients for Windows from Linux with Wine and PyInstaller, and it works. And at the end, both clients should be the same, almost, and should be able to connect back to the server. So that's what we will see. So what was the procedure? So on the Linux, I will just compile and show you how to compile a simple binary, no cross-compilation, Linux to Linux. It's the same for Windows to Windows. Okay. So here, the command is PyInstaller clean, just to clean some previous cache, one file, because I want everything in one single executable. And I will just name it server, which is, that's the -n option. So I'm launching the compilation, and it will build a native binary. So it did it successfully. I'm going to the dist folder, and I will just show you that you can see the server binary. I'm not fooling you. This is a real executable. So that was a Python 3 before. Now it is a binary, and it works just the same, such as the Python script. So you recognize the different option here. So that's okay. I compile the server. Now I will just compile, and it's not really useful, but Windows to Windows stuff. So again, I will compile the clients on Windows for Windows, just so I want a PE file. Again, it's compiling. Again, I'm going to the dist folder, and here you can see that I compiled client compiled from Windows, and again from Windows. Oh shit, I'm on Windows. Sorry. And it works the same. I went from a Python script to a binary, and right now here's the magic. I will cross-compile a Python script from Linux for Windows with Wine. It should work. So the syntax is pretty simple. So you call Wine, you tell him to use pyinstaller.exe that I install in my local Wine repository to provide a standard binary, so one file, the clients, that will name just client compile from Linux, just to see the difference between the compilation. Sorry, I messed. I need clean. So it should work, let's hope. And in the end, I will try to connect the cross-compiled stuff to the Linux standard module, and it should work. So apparently it worked. Again, so I can see here the client compiled from Linux, that's the new version. I had one because I tried, but here's the good one. You can again see that it is a true binary. Here it's saying that it's a PE file. Here I should see, you should see that it works. Okay, right now, so program should work. I will just try to connect them. So I will just break down the syntax. So first I will be launching the server on Linux. So I'm launching the rel binary and the rel rpavate script. Verbose, server port here, server IP listen on every interfaces, proxy IP and proxy port. So I want on my attacking machine, just like proxy that you can proxytion after, it should set up a socket listening on that port and tunneling the stuff to the client, so to the target. So first I'm launching in on server side, and the second step is to to compile, not to compile, to execute the client compiled from Linux to connect back to the server waiting on my Linux box. So I think the IP of my Linux box is 1. Yeah, okay. So let's see. And it works. So here's the tunnel. I received the communication from client to a server, and here you can see that with netstat that I do have my tunnel, my local tunnel and my attacking machine, and every traffic I will send to this socket will go through the tunnel and go back and go out from the client that I just attacked. So that works. Thanatos, thanks for the tricks. So finally, maybe how time? 1 minute, okay. As a quick conclusion, it's pretty easy. So CSV kit everything, data echo everything, GNU parallel everything, Jython everything, Iron Python everything, Freda everything, and pinstall everything. Thank you.
Any questions? All right, if not, thank you very much.
Thank you. Thank you for your time.